That's some choppy looking number countdown video stuff. Huh, weird. Anyway, hello, wait a minute. Dear YouTube people, is it actually working for you? Because I'm not seeing anything on that side. I don't know. Anyway, how's the rain? So far, no actual rain, right now. Also, Spies Mud, I see you being the only person to recognize my Third Rock from the Sun reference there. All right. Here's the deal. It is very rainy this weekend again. Very stormy, rainy, all that fun jazz. I'm going to attempt to stream all 3 days. We'll see what happens because I kind of have to be here at the office no matter what anyway. So let me explain why. This is cap reforming. This is a chart for, well, a deck writer 2. So here's the deal. This thing has 4 monstrously large capacitors in it, and I'm attempting to reform them. It's not going great. Look at it. That's under chat. Hold on. Look at this little, like, hold on, I'm gonna cheat. Meh. Look at this weird divot thing right here. I don't like that. And then I don't like that after that, this line stays horizontal. That doesn't feel right. So I'm wondering if this cap is leaking or something. And by leaking, I mean current. Like, yeah, I'll just feel it for giggles here. Not warm in the slightest. So, yeah, I don't know exactly what's going on there. So that's cool. So I'm running that in the background because, well, that chart is 4 hours long already. This is taking a while to do these caps, and I'm running them slow because of that weird dip bounce thing. I don't want to overdo it and have them blow up. So, Majeko and 16 Raiders, hello and welcome. I don't know why Deck Talk didn't activate. Let me just restart it to be sure, I guess.
Deck Talk is now online.
End of line.
16 Raiders from Aleratec have joined.
End of line.
All right. If they blow up, think of the content? I would prefer not. All right. You know, some other countries' mobile signals keep working in the rain. Yeah, but that's terrible here. Hype intensifies Ben, yeah. Good luck with the internet. Yeah. So, um, so yeah, I'm working through that. Here's the thing. There are 4 gargantuan capacitors in there. I haven't done the biggest one yet. So I'm probably going to be spending the next 2 days working on reforming that one. And again, I'm going really slow, although it doesn't really feel that slow. That's 1.5 milliamps. Or is that 2? I think that might actually be 2 milliamps minimum. Yeah, that's 2 milliamps minimum, and it's still not going that fast. So, yeah, how many farads? This one is a 14,000. This one is a 37,000. Never mind. Good grief. The next one, though, that one is 33,000. 60 volts. I'm not looking forward to that one. My power supply here isn't actually going to be able to bring that up to full scale. I'm just going to do it to 50 like multiple times and just hope for the best. So that's cool. Yeah. I'm really not sure about this one that is 37,015 volt though. It's really looking bad. So really power the computer. That'll do the rest. From 50 to 60, I think it'll be fine. But the rail that it's on probably doesn't even go up to that point. So it'll most likely be okay. They should have been overrated because you wouldn't spec a 60 volt capacitor for a rail that is at 60 volts. That would be a terrible idea. So 50, in theory, should be good. I always do a full scale reform because that gives me the most information about the health of the capacitor. Because if it has never been run up high, that'll give me an idea of how much it's degraded up there. Anyway, bring it up to 50 volts a couple of times and stack a second supply in series, bring it up to last. Yeah, I was thinking about that, Ben. I could do that. I don't know. The other thing is, like I was saying, they shouldn't have it anywhere near that voltage, so it shouldn't matter. But, you know, I probably will not. I probably won't. I think it'll be fine. Okay. Let's see what else here. I think that's it. I've been working on a bajillion things this week. Don't get bored waiting. Use your pliers to discharge the last 40. No. So that's actually part of the cap reforming setup. The 34401A will beep, and then that tells me it's discharging. I have to wait until that shows 0, as in no current transfer, before I will take anything off. So, given the research, we did the other night, in particular decorator 2, might go in the yellow it because what are you going to do with the one that works anyway bucket? Can this thing take current loop? Because if it can, then problem solved. I'm sure I can find a current loop to RS-232 adapter. I'm not that worried about that. It's not great, but I think I'll be able to solve it. So, okay, what else? Guessing probably not, but yeah, an adapter is an option. Yeah, I wouldn't mind having an adapter anyway, because, like, I got enough weird stuff that it would be beneficial. Like, I think the TI Silent 700s are current loop only, so, to be able to actually use those in the future, wouldn't mind it. Yeah, I'm sure those adapters exist, so probably just wouldn't hurt to buy one. And hook it up to Linux or some old Unix emulator or something else. So yeah, I got plans. But the reforming needs to finish on it, and it's taking so much longer than I thought. Need a PDP-11. I keep looking. They haven't listed one yet. I'm hoping the same place that I bought this from finds one of those in their back room too, but we'll see. All right. Have we done enough yakking for 10 minutes? Should we actually do some work? Okay, here's the thing. I was trying to get into this. I've done so much stuff this week. I have literally no recollection of what we last did with the RoboRacer software. I think I got my bin-queue merging tool working, and I was able to extract audio tracks. Was that what I did? I don't remember. Was it working on Blue Books? I don't know. I think I need to reassess where we're at with that and then figure that out and then start from there. I think the main focuses needs to be extracting audio tracks from a red book, from a blue book as well, not doing the data from a blue book because that's just impossible with the software that I currently have available to me, that is. And then also extracting from an ISO disk, just a yellow book. So I think that's where we last left off. Can't remember if we did blue book or not. Yeah, I don't know. Last time we were integrating bin merge replacement. Don't recall if we got anywhere past that. Okay.
Oracoon says CHER 200% C help me chat. I need you to work as my backup memory
Yeah.
and to be accessed.
End of line.
No kidding. Thank you for the 200 bits, Chloe. I loaded 2 disks at once. I do remember that. Yeah, you're right there. That sounds familiar. I'm good at this. Have I ever been a package handler? No. No percent C. Wait a minute, that's a good point. I don't know. Deck Talk doesn't seem happy today. I have no idea why. I'm not gonna sweat it too much because I don't know. It's been weird. Let's see. What's the other things? I think that's it. All right. There's one thing I'm going to show you all over at the. You're also looking at getting things on PyPot. Yeah. That's not like mission critical. All right. I would like to. That would make some things easier to handle and would make packaging stuff better. So maybe, but I'm low prioritying that right now. Okay. Let me see if this is fixed. Yeah, let me close a couple of things over here. Okay, is this working? Come on, reload the page. Ugh. Oh, that's disappointing. All right, well, I'll just do this way. Behold, the manual for HP EGS. Kind of. So this is the HP EGS 2.2 Series 200 CAD modeling software syntax manual. So this tells you how to use the software. But that's it. We still don't have software. I already have this scanned and uploaded on archive.org, so there it is if you want to read it. So this is the CAD software that would run on that computer. So it's real. It exists. The software is out there. But yeah, I was kind of hoping, so I have this right here. I was kind of hoping that there was going to be like a floppy folder thing in here that would have like the discs, but no. That would have been too nice. Helicraft, we don't technically know that it does use the prom for a security ID or something. We don't technically know that it does. We're just, or did we find out? Actually, I think we read in a HP journal or something that it does actually. Okay, never mind. It's probably going to. Or am I being notified by my phone? Hold on. Stupid sponsor garbage, blah, 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 blah. Okay. But yeah, this is really cool. Theoretically, we could actually use this to reverse engineer how HP EGS works, and then make our own. It actually goes so far as to detail the file format even for how it saves data. It does it sort of at the end. I had a brief flip through the whole thing. I apparently did not white out the pages enough. Oh well. Somewhere in here I believe it does. Anyway, so yeah, there's now way more information about HP EGS than there previously was, which is super cool because there was almost nothing. So, Aleratec KiCad X import plugin, yeah. But yeah, it's just archive file format. Okay, archive list commands, recreate any drawing. Okay, so that's part of it. Yeah. So, yep, that's really cool. It's like teasing me, taunting me, like, here it is. It's real, it exists, but this is not the software. So close, but still exactly as far. Come across any project info about protocols for Primera? That's a scanner, I think, or microards. I have no idea. Disk publishers. Oh wait, they're both CD things. While researching disk publishers for archiving. Yeah, I think there's one page that's got maybe some information about that. You're just looking for the command schemes. Does it not have the source code listed in the back? No, it doesn't. That doesn't prove it exists, merely that it existed. Oh, that's a horrifying thought that every copy could be gone. I mean, theoretically, you could be right. But since it was like $10,000, I have a, well, I don't know. The kind of people who could spend $10,000 on that are the kind of people who just throw it away when they buy the next shiny thing. I don't know. It's annoying. So yeah, I finished up scanning that through the feed scanner this morning. So yeah. Excuse me. One moment. Robo Racer LS. Okay, so there was some information about the commands. On the page that had the Robo Racer LS stuff, yeah. So Primera, Composer, Conductor. So this might get you. Daniel, you are on YouTube, aren't you? One moment. There we go. That might get you in the direction for how to utilize one of those, if that's what you were looking for. Of course, could have all rotted in storage too. Hopefully not. Hey, look, my name's almost sort of not pink on YouTube. It's kind of like a burnt orange.
I've subscribed at tier 1. They've subscribed for 33 months, currently on a 33-month streak. And says %C stop being a cat.
End of line.
I don't know why that stopped working. Schmide, thank you for the 33 months, though. I don't know why the %C isn't working. No problem, Daniel. I knew I had found that, and I remembered how I got there. Okay, so this is probably the exact same folder setup as I left it. Actually, let's just look at what the last modified outputs was. Curvature, space. That's not a good sign. I don't think that'd be it. Bin queue split. Bin queue. Back. Okay, this would have been right at the end. So we generated flax from music data. Let me make sure this actually looks correct. And skip, I don't need it. That looks like music data. There's stuff at the end and the beginning. That's spacing. Okay, that looks correct. I'm not playing that because that's like uber copyrighted. Okay. So I just quit after the price is jacked up. Oh, you know, actually, you could be onto something there if somehow that affected it. It shouldn't. I just changed a 1 to a 2, but I don't know. Let's see. Okay, so it looks like I did not attempt to do a yellow book disc. So let's do that. I'm going to plug the Aleratec back in because I was using other stuff that needed power and I wasn't Aleratecing. Okay, did you accidentally make that change on an old... I don't know, man. I literally no idea. Okay. Brain first gear. Okay, we need to go over to... nothing there. I just need to push the USB button and then launch this. Okay, disk rip, settings, APLS, and W. Okay, it's a good thing you can have multiple things running on multiple ports on multiple computers. All right, looks like curvature space may have been the last thing we did. I don't know, because this should be sorted by the time here. So maybe we tried to and it didn't work. I don't know. All right, let's F5 that. Okay. If Beck worked, that means that Redbook works. I don't want to try that again right now. Maybe I should, just to like repeat tests, like make sure things didn't break more in the background while I wasn't doing anything. But that sounds like smart. So let's do something else. Where is my suite of test discs? Here they are. I want to put Lego Racers in there because it is the most boring, bog standard yellow book disc you can imagine. So it's the perfect test to make sure that ISO extraction works. So let's just do this. Lego ISO. Go. All right. Oh, you can't see the robot. That's probably all broken right now, so let's just not worry about it. By that I mean the camera for like viewing that. Because I did something. Yeah, there was an HDMI splitter that I had to remove. So that doesn't work anymore right now. You're imagining the robot? Yeah, so there's like an arm, it goes, and then it like, and then it picks up a disc, and it goes, and then it goes back, and then it goes down, and then it drops the disc, and then it goes back up, and then now, because we have the camera, it goes back over so it can take a picture. And that's what the robot does. See? Picture. Archive.org still hasn't made the web version of the EGS manual. And I like how you can know for sure that I'm the one who scanned the HP EGS manual because I misspelled reference. Like you can feel confident in knowing that that was actually done by me. On the game of Hunt the Screw? Oh my gosh, 54 minutes. Washing machine door, that one sounds slightly important, so I can understand you going to that level of effort. Alright, output, Lego ISO. Gonna see Tron today? No, definitely no. Why would I go to a theater for that? I don't know, I may go to a theater. I don't know. Has anybody seen it? The only question I want to ask is, do they do anything cool like the dynamic aspect ratio that would be best in a theater? Because if you don't know, Tron Legacy changed aspect ratios depending on whether or not they were inside the grid or not. Shelby's busy sailing the high seas. No, I can just wait for it to be locally available without having to pirate it. My gosh, there are other options. Okay, there are no WAV files, so I don't know why I did that. ISO, Lego ISO, beautiful. It fully worked. Awesome. Okay, well, that's good. I'm gonna have to watch that again now. I never noticed that. See, okay, so here's the thing. I was gonna lead to this. I don't remember if the home releases did that. I watched it in theaters, and they actually had like curtains that they moved back and forth as they did it. It was incredible. Physical and digital releases exist, I know, right? Your only options are limited in person or pirating. I mean, like, yeah. Get the movie experience at home because the camera's in the movie. It happened in the latest Mission Impossible 2. Okay. Well, did they just do like 2:35 to 1 for like serious scenes or something? Is that because I don't count that, especially if they do it where they'll like have it be like boom car chase crazy and then it'll move up like that. That doesn't count. See, anyway, it doesn't count then? Yeah. Because that's really common. Like, Top Gear did that all the time. All right, now let's rip the blue book because that worked perfectly. So let's see what the blue book does. I think what happened is they do change FOV when they do dolly zooms. It was an annoying thing Top Gear did. Yeah, so you might understand why it's overplayed and I don't count it anymore. Okay, so if we did rip this, this must have failed. So bin queue split. I don't know. So Lego ISO, that generated the proper bin queue, which should be effectively the same as this. Yeah. And then we know Beck worked. Yeah, so let's try the blue book. I don't know why it looks like the blue book won't work, but yeah. At least heavy-handed ND grads are timeless. I will say, when I did the Windows XP Media Center video and I went back to find some 2005 Top Gear to play for the TV section, it was funny how harsh the contrast was and how tinted the video was. All right. Curve. I don't know. Merge. Whatever. I don't care anymore. Start. Also, let me real quick. I want to grab a keyboard here so I can click a thing every now and then. Okay. We're at 13.6 volts. We're going up to 15. That's the goal on the reform. Up here for me, the X Turbo is, oh gosh. We're pretty heavy on the grading. Wait, why did it just eject the disc? Ooh, that's, that didn't go correctly there. All kinds of things went wrong on that. That's weird. Please There's nothing wrong with the disc. Okay, well, we just discovered a fail by accident. So the disc got put in, and for some reason, the software rejected it and tried to do an eject, and that caused it to try and load the next disc, which would have offset all discs in the queue by 1. So a bad disk can mess up the queue. Photos are going to be really handy. I don't know why that happened though, so we're going to have to restart it. Gotta love edge cases. Yeah, that was a weird one. Except 2 discs at once now. That would suck if the clamp got messed up. Okay, let's try this again. Disc grabbed, plunked in, all normal like. It's taking a picture. Am I the eventual end user for this system? Yes. I'm designing it in public open source and trying to accommodate other solutions into my software so that other people can use it. Because there are a couple of other people who are using this, but I'm probably the only person who will ever have this robot that uses this software. All right, looks like it's going to work this time. It is probably a weird CD. Beautiful. Okay. So we'll see what this does. Doesn't have to be foolproof. No, it would be nice for it to be foolproof, though, because it would make it more robust for when I try to queue up like 100 discs at once. That would be the reason to have it be foolproof. Because the whole point is that this thing can queue up 200 total disks at once and then just work through them. So the robustness will come from the inattentiveness. Wait a minute. Why do I see... I think Beck was already over there and I didn't even notice. Where is that at? I think stream proof would be a fairer term because it's being on stream that causes the confusion and distraction. Live demonstrations best way to find faults. Yeah, no kidding. I forget why it's taking so long. I'd say I forget because was it Music Brains that takes forever to reject this disc or build the disc ID or something? No, because that was with Poker. Why is this taking forever? There's no logs. Said it gave up and assumed it was a weird CD. Copying photo. No, it's all normal. I'll give it a little bit more. And see what happens. Let's see. What else we got going on that we can yak about while we wait for that? Now I have to watch that Top Gear segment again. What Top Gear segment? Oh, on a local. That's cool. So response because rain. Oh, you know what? Genuinely, it could be that. If it tried to do a Music Brains request and it like missed something, that could 100% be it. Well, just gave up on trying to do something. Okay, hold on. Let's try and look up URL lib timeout. URL lib to timeout. Yeah, I think it's about to start, yeah. So there it goes. Disk not found or bad response, yeah. Previously on this, it does not find it on Music Brains. Optional timeout parameter. Oh, is it per request? Is that why we can't set it? Because I think I tried to look up this before. So if it has to be set in the timeout, that would be why it doesn't work. Or if it has to be set in the request. Oh gosh, what is it? Local, lib, Python, packages, blah, 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 blah. LMN. So it's not there. So in that case, system. It's probably user, share. No, maybe. No, user, lib, Python 312. No, it's not there. Well, how do I wait, I know how to do this actually. Wait a minute. I know exactly how to do this. Python 3, 1 plus 1. No, I'm just kidding. Music, import, music, brains. Is that, no module called music brains. Yeah, and music brains NG. That's, and NG music brains? Handler, data, no, media, CD. NGS, good grief. Okay, print, music brains, underscore, underscore, file, underscore, underscore. Missing parentheses. Blah, 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 blah. There. Music brains, NGS is not defined, seriously. Import S. There we go. Yoink. Okay. Since this one's giant, let's look at it. Okay, blah, 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 blah. Socket. I don't see URL lib there. Okay, could it be in util? No. It's just, no. 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 Running time logging, hash lib, locale, XML warnings. Does it import it somewhere else? URL lib. What? Give undivided attention again, yeah. Request, okay. So here it's gonna do some kind of request, URL unparse or URL debug HTTP handler. Okay, so where is that from? What is compat? Music brains import compat. URL lib. Okay, so it does use that. Got it. Okay. So I was like, really? Okay. So then, timeout. Socket timeout. Okay, where are they? Up. Those are the only two places timeout happens. Safe read. So request timeout. URL open. Control F. URL open does not exist. Okay. Cool. Request init URL data. Trying to figure out if we could just modify it to have a timeout, because it only matters on this computer, the one in the office on the garbage LTE connection. If we can have it be, if it can have a good timeout here, that's fine. I don't really care. I don't mind locally modifying the Music Brains thing here. Why is this taking so long? Oh, I bet I know why. And if I do this, will it get faster? No. Okay. I had, yeah, Ben, I'm trying to figure out how we can add a timeout for the URL lib2 call. I'm not sure where to do it. Anyway, I think I had I had the scanner, the ADF, plugged into the same hub as the Aleratec, and it may have made the Aleratec pick a slower USB speed. So after this, we might want to restart the whole thing, hub and Aleratec, just to make sure it bumps it up. Has an arithmetic back-off algorithm, extra 2 seconds per retry, but doesn't have any timeouts of its own, and it doesn't let you specify request session objects with one. Yeah, I know it doesn't normally. Only option to use sockets set default timeout. Okay. Does sockets exist here? I'm gonna guess not. Control F, sockets. No. There is socket error and then socket timeout. Okay. So let me look at this. Socket set default timeout. I'm very fine doing this. So does this work kind of like the weird request object in Flask, where it's like a global static object, and if I run this right before I call the Music Brains request, then it will be modified for that? Okay. So what you're saying is I could set this. There's probably a matching get as well, I imagine. So I could read it, execute the Music Brain query, and then set it back to normal for anything else after. Applies to all sockets that don't have explicit timeout change. Okay, configured. Okay, import socket. Is it plural or not? Because I didn't set default timeout. Looks like it's singular. Set default timeout. It's default timeout in seconds. Okay, so I just want to do this. Singular. And then set user entry, blah, 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 blah. Disk ID read, and then fetch results. But first, set default timeout to 3. I think by default it's none. That's brutal. 3's probably a little rough, but like I don't care. Okay, but how do I get it? Get default timeout. Easy. It's almost like I know how to read. Timeout equal this, and then boop, adoop. Okay. This is still going because it's going really slow. It's about 2/3 of the way done, I would say. We can cheat and look at how much it has been in the past. Scram size is 843. Okay, it's got a little ways to go. Why so slow? It's halfway now. Line 156, same as 159. I don't know numbers. 156, 59. No. So we're getting the timeout that it was set to before I change it. Then I change it to 3 seconds. I run my Music Brains request, and then I set it back to whatever the default was. So if the default was none here, we should get none as our return. I change it to 3. I run my web request, and then I set it back to none in case there's anything else that matters for it. So that I want to try that. But yeah, what am I working on today? I almost remember. I actually don't know quite yet. Why? Line 158 empty? Yes, it is empty. Why? No particular reason. This line intentionally left blank. There you go. Actually, we should only have one. There we go. Even better. I've seen enough Python at work the last 2 weeks. I'm sorry. But I had stuff before. Writer is 157 that broke. No, 157 just doesn't have... Oh, that looks weird. Maybe we don't want that. Hold on. Wait. Oh, I know what happened. Okay, hold on. There we go. View, word wrap. Oh, it is off. Okay, I'm just an idiot. Never mind. There we go. I had turned word wrap on because I was writing an email here and like I was taking his notes in there and yeah. Anyway. Good catch, Adrian. Disregard your previous message. Oh, yeah, no, I was dumb. Yep. I blame Python, though, and its stupid white space rules. Because I'm sure in C I could come up with a better solution than this monstrosity here. Okay, dude, why is this taking so long? 3/4 of the way done, at least. Ugh. Trying to poor thing the whole thing to NCC, yeah. Totally left field question. Have any of you done Unreal Engine development, like recently? I'll use Godot. This has to be Unreal Engine specific, I think. Why is your CD 800 megabytes? Yes, it is reading subband data. Specifically, though, this is reading Scram data, which I really don't understand what it is. It might actually have the Reed-Solomon parity bits. Not sure. Not super recently done stuff, UE 3 and 4. Is MIP mapping free in Scram, like scrambled? But in Unreal Engine, is MIP mapping free? Do you just like basically tell it like generate MIP maps and then set the MIP map level to this or whatever? Just out of curiosity. It's probably, if you barely used it, then it would be, I think map has been basically computation. Well, I mean free as in how you set it up in the material properties. Because like I don't know how you do graphics settings in something like Unreal Engine. Like, I mean the actual configuration options or, like, enabling a thing. So, I meant for, like, development perspective. Is it free? Because, like, if you're doing LOD for, like, 3D models, that's another kind of problem. I know for a fact that you can auto-generate LOD models and then have that be done. I don't know if you do that with an external program, though, or if the Unreal Engine SDK comes with something and does that kind of thing. But yeah, I was just curious if mip mapping is free. It's a part of the base engine last I checked. It's not in the material properties, it's being text properties. Okay. So it should basically be checkboxes, essentially. Mostly curious because I was playing a game that I believe that was made in Unreal Engine, and it does not have mip mapping. And I'm pretty sure it is the cause of some severe performance issues. So probably no LOD either. And I was just curious if I should email the developer and be like, hey, just go do this really quick. They're giving your own MIP textures to be higher quality. Yeah, they can be freely generated downscale versions. Yeah, that's what I was figuring. Like, yes, it would be better to generate them yourselves. The same with the LOD models. But if you can do it for free by just basically checking a couple of text boxes and then maybe adding a menu option for it, that would make it a lot more likely to be actually implemented by a game that's already released. Why wouldn't it improve performance? Doesn't it reduce the amount of computational mapping that has to be done with higher resolution textures? Mapping LOD models reduce performance costs together? Yeah. Won't save memory bandwidth. No, but it would save GPU calculations. I think, at least. Could be more LOD model, reducing performance costs over the mip mapping. Okay. Yeah, because I'm pretty sure that's also a problem. Didn't know how free that was. I could see that being a lot more difficult to do. Well, the mip mapping itself will require some computation just to decide at what range it should be applied for which level. In theory, it would also take more VRAM because I believe you would have all of the textures loaded, including the smaller ones. So it would take, like logarithmically less more VRAM because they would probably be quarters or less. Speaking of logarithmically, let's look at our reforming. Where are we at? Okay, we're at 14.84. Oh my god, or 14.23. It's so close. Oh, it's so close. 2x RAM. I guess. I know mip mapping's been around for a very long time. What am I reforming? Capacitors. To using 1/3 more RAM, just fewer iterations. I mean, I guess if you're doing like VGA palettes, that matters. I mean, that's still, so that's 1/4 instead of 1/2. So that's why the 1/3 more RAM. set the map settings, drop down to anything that isn't no maps. You can also set LOD bias, which affects which map is highest level. Okay. Hecubus, I did go over at the beginning of stream more. It's Deck Rider 2. Well, Schmide, it just depends on what factor your different generations are. So if you did half resolution, total pixel count, then it would be 2x effectively, because you would have that file increase exponential there. It's okay, Flare Spire. It doesn't matter. It's not. That's not going to mean anything to me, so you don't have to bother. Dude, why is this taking so long? Oh my gosh! I definitely should have just turned it off and on again. Oh, I regret it. We only got 50 megabytes left though now. Yeah, Dratini, I understand. I mean, I don't understand the individual color channels part, but whatever. It's probably just graphics nonsense. But yeah, I understand conceptually. Mr. Cow or Mr. The Cow. This is already a big bad one. But this isn't compiling. This is ripping a CD. This is single threaded. This is a thread ripper. But also, it doesn't matter because I'm not buying a modern computer. This is not happening. We're at the point now where there is almost nothing that I can't do with my older computers that I want to do. I mean, sure, there are some things that could be done faster, but there are other bottlenecks that are impeding them that just more power isn't really going to solve. Not even single threaded. I was just trying to simplify it. What I really think is going on is that, dude, why is it not increasing? I really think it like set a read rate that wasn't going to be throttled by the USB bus, and then it just stayed there. Oh my god, what are you doing? It just tried to eject the disk, and the oh gosh, oh no, 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 no. It's about to try and punch Robot in the face. Hold on. Dude, I don't know what this just did. I don't think it knows what it just did. These drives run at 48 speed already when they're not being stupid, so... You know what? Hold on. I'm just going to turn the whole thing off. Boom. Powered off. Problem solved. Close the program. There. All dead. Okay? It was about to try and eject the drive tray into the robot arm because it tried to unload the disk, but the tray didn't eject for some reason.
Oh, man. 200 CD ripping robot fight streamer film at 11.
End of line.
Yeah, no kidding. Thank you for the 200 bits, Chloe. All right. Powering robot. Did I just see the lights flicker? Jeez. Hungry, hungry robot. Where are we at on reforming? Why is it not loading? Oh, because I need to click this. Wait, did it beep? Is it done? Did I miss it beep? Wait a minute. There's a 13 volts. I can't tell anymore. No, it's still going. I don't know why the terminal program is extremely angry and it keeps flickering. I think it might be Flask requests trying to clear the page to print something, and then the curses library prints back over it and it just flickers back and forth constantly. It's awful. Anyway, why doesn't this work anymore? You know what? I give up. Whatever. I don't think it beeped. Oh, Mr. the Cow, no, definitely not. One CD, yes. The about 1,000 CDs that I need to rip, no. I think we are still net positive on time. This terminal's like... Okay, Dolphin is... Yeah, I'm going to restart the computer. Okay, the computer might restart the computer. Why did it say CD-ROM 3 times? Good grief, it is all messed up. Yeah, Dratino's got it nailed. Critical medium error on dev SR2. Buffer IO error, dev SR2. Oh, geez, that's hardware. You can't see it. Yeah, it's cranky. Just gonna turn off USB. Give me my CD back. Hopefully I didn't kill this drive when I had it double stack discs or something. I don't know. Yeah, I'm just gonna reboot the thing again. Why not? There we go. Bonus objective we can do sometime.
For Lazara subscribed at tier 1. They've subscribed for 12 months. And says when in doubt, reboot all the things.
End of line.
Yes. Koi Wazara, thank you for the tier 1 sub and for 12 and 12 months. I appreciate that. Anyway, bonus objective. We'll break out the test bench at some point and cram this thing in there. That is a Magewell VGA capture card. Didn't know that they made a PCI variant of that. Found out about those. Picked one of those up because it was not horrifically expensive. And I would like to know what it's like because I find the Magewell stuff to have incredible Linux support. So I would really like to see that. Ooh, did this do weird thing? No. Python has not been my friend today. On the stream computer, that is also the capacitor reforming computer, when I powered it on for the first time today, somehow it restarted the capacitor reforming Python script. I don't know how. So I think KDE's activity preservation nonsense was trying to do something there. And I don't know what started it. I didn't have like a terminal thread or anything open with it. So I just did a PS AUX list to get all of the ones and then grepped it to reform and then oct that into just the PIDs and then kill 9'd all of those. This is weird. Just jealous about GPIB? Yeah. Alright. USB hub active. So now there's like data stuff. Pi disk rip. Okay. Let's see if this behaves not dumb this time. I don't want the reforming software to always be running. Easy. Because the GPIB stuff sucks. It's very unreliable. Curve merge 3, I guess. I don't know. If this does not rip at a high rate of speed, then I'm just gonna give up. I don't know. It better behave correctly this time. Alright, let's see what happens. Not GPIB, the Linux GPIB drivers. Wait, what kernel was it that got Linux GPIB stuff inlined? Could maybe we, like, use that now? Is Ubuntu new enough now that that's actually viable? Can it be a media issue? This media is very issue. But all Blue Books are, so I don't know. We've ripped this one a lot. So I don't think it's that. Oh, did I bet my GPIB unless upset now? No. I wouldn't badmouth any viewers, except Dziak. He deserves it. We did save the redumper stuff, right? He's really angry because I IEEE 488. I used its full name. Okay, so in theory, it should time out after 3 seconds. Okay? I don't think it worked. I'm starting to get thin from the laser. Gosh. Yeah, I don't think the timeout setting worked, unfortunately. I don't know why. Maybe wonky thread nonsense. Well, while we're waiting for it to do that, this does not count as the being slow. I'm just going to put my Microsoft Surface away. Because I forget. So plagued with problems. Oh my gosh. It's annoying when it's the things that are out of my control that cause the issues. They just make it so that I can't, like, fix it. Like USB speed. Like, come on. How can I predict that that's going to be a problem? The internet stuff. Like, I could maybe, I could theoretically pay for faster internet. It's not necessarily going to be more reliable internet, because think about all the times that my home internet goes down. Again, that's the same service provider that is the only one I can get here. Place with typewriters. Nah, I really don't want to take time off of this. Because it's kind of frustrating just having projects that just sit around. Like, it needs to be done so it just works. I don't want to look at this and think I could use that, but I can't. There we go. Finally. Jeez. Like, for example, Dot over there just taunting me. I ordered caps for it. They're at home because I forgot to bring them. No. They're in the front room. So they're here. We have caps for the Dot now. I almost remembered to buy enough for 2. Because I forgot I own 2 Dots. So, the good news is that I overbought all capacitors. I minimum order quantity 10 of everything, and I don't think it needed any more than like 3 of each value. So I think there's enough for 2. I just probably would have bought more because I wanted to have extras. Caps, wiki, let's just look here. Recent changes. That's right, Andrew's Awesome has been going to town. Computer devices. Dot. Let's just look at this really quick. Quantity 1 1 1 2 1 1 2 1 1 1 1 1 1 2 3. Ooh. 1 2 1 1. Yeah. Computer devices. Gee, I wonder why they were out of business. It could have been because they had no one who could design for production, could it? Oh, 4 on that one. Ooh, crazy. Oh, that's on the power supply. They probably didn't design that themselves. One of these, you could merge a couple of the values on it. I forget which one it was. Is it this? Yeah, that one I screwed up. I think these are the same. No, it's this one. Those are the same. So you order 3 of that. So yeah, I ordered minimum of 10 for everything except the horizontal deflection cap. I did pick a part for the horizontal deflection cap here, Helen Croft. I'm curious to have your input on this idea. So I was thinking you could put 2 of them in parallel. So this is a 10 volt high ESR ripple current, or no, high ripple current load cap. So I think we needed 5 amps of ripple current carrying capacity total or something like that. So I was thinking you could put 2 of these in parallel. All the other specs are equal. I don't know that my horizontal deflection caps are bad. I'm probably just going to leave them in there and hope for the best. Oh, it beeped now. For definitely sure it beeped. It just finished reforming that cap. Good grief. That's a terrible one. We're going to just run back the exact same settings over there, but I'm going to restart the whole cap reforming. Well, actually, no, I don't need to restart it. It's, the web page got messed up. Anyway, there's too many things I got going on right now. How fast is this ripping? Because I don't hear the drive going to town over there. It's going slow again. Why? As soon as I said something, it tried to eject it, even though it didn't finish ripping it. Like the one time I don't have the camera pointed at it, it starts behaving super poorly. All of this just reset, I think. Maybe something weird's going on with the hub. Maybe the hub is failing. Oh, that would suck. Not the internal hub. I think my desktop hub, maybe. That would be very disappointing because I like it a lot and I don't think I can buy another one. Each one has a timeout that can be set of reach 2 seconds as the middle ground, alternating instead of... Blame Jesus? Yeah, no kidding. Well, all right. Turning out the robot again. Unplugging it from the hub, though, this time. So I have a nice long cable for it. I'm going to try and plug it directly into the back of the computer. It might even reach. So I will be back in one moment. I'm not going anywhere else. I'm just going under the desk. The usual cable shenanigans. Where's my flashlight? I'm pretty sure it's within 3 feet of me, but I don't remember exactly where it is. There it is. Ah. All right. Timeout's 3 minutes. It said it was a float second value for timeout. No. It had started ripping. It was just doing it poorly. USB cable did not poke down. Okay, cool. Yeah. Come on. Okay, that time I think I got it down there. There it is. Okay. Now, are there any free USB ports on the back of it that doesn't reach? Of course it doesn't reach. That would make sense. Okay. There's a Type-C port, which is fun because it technically is a Type-C cable. Yeah, it's like 2 inches short. Are you kidding me? Ah. There's no other way to route it. The problem is that this desk has one of those privacy shields, and it has to go down and then back up to plug into the computer. Correlation definitely applies causation, therefore the camera is necessary. Your logic is irrefutable. All right. The problem here is that the cable that I had plugged into the back of this, I shaved the plug on, so it actually is a little longer than normal because the C panel connector thing doesn't quite fit cleanly. So I don't know if I could plug a longer USB-C cable in. Let me see if I can. No, it doesn't. It does not seat. So it has to be that cable, which isn't super short, but it's not long enough that this is going to work. Just pulling the whole robot and 8-inch drives over more. Give me my flashlight back. So 99% of the issues just the cable being upset? Yeah. Privacy shields make a lot of sense on a streamer's deck, yes. I mean, they're just like school desks. The best part that you can't even see is, you know how it's like a right angle desk setup? It's not supposed to be. It's 2 desks. One of them slightly overlaps the other, and it's just sitting on pieces of 2x4 to do that. Drill the shield, I could, but I would have to have a hole saw here, which I don't. All right, it is now plugged directly into the motherboard through a C port. We'll see how this goes. Powering it all on. 3D print hole. At least just don't want to cast summon deck talk. I mean, it's not like that's a problem. I can stand, don't worry. Let me look at capacitor stuff really quick. All right, it's down to 0.8 volts. It's one of these buttons here. There we go. All right, not that. This. There we go. Okay, so the web page gets wonky. After a while, annoyingly, or if you reload the web page, this happens at the point where you reload it. So, yeah. So I'm just going to do this. Setup. No, kill reform. Okay, I'm going to apparently close the page because it's borked. Get back your keyboard. Okay, why is this running so bad? Like, that's really bad. Okay, kill reform. Back to setup. Okay, target voltage, 15 volts, resistor 220. We're going to set minimum current to 3 milliamps, maximum current to 5 milliamps, and then we're going to do 15, and then underscore verify. Start reforming. This is higher current than I had initially done it for. So let's just see what this looks like. So for those of you who are not aware of this software and the whole reforming process, effectively, what I'm looking at here are these, the blue trace here. The more curved the blue trace is, the worse behaving this cap is. So far, that looks pretty good. There are two curves we need to look at. We need to look at the individual stair steps and then the entire thing once it's done. The flatter that line is, the healthier that cap is. So far, this looks okay. It's a little high current on there, so I'm not totally convinced yet. We're going to run this again at half the current after this. I'm not going to start the 60 volt cap today because we're not going to get anywhere near close to done with that. So I just want to see this. This is, again, pretty high current. This should work out well enough. The stairs, or the sawtooth here, not bowing in is kind of the inverse of that. That's a good sign that it's looking healthy. Let me get to a place where I can read chat here. Submit an issue to this GitHub. Yeah. I'm actually thinking about rewriting the whole thing because I hate myself. It's point just remove the privacy shield and be done with it. The desk is not structurally sound enough to handle that. There are no diagonal supports for it that could make up for the privacy shield, unfortunately. Overall, that's looking good so far. If you were here at the start of stream, this is the same cap that had the weird dip down and then back up. So far, this looks good. This cap may have been saved through reforming. I'm becoming more convinced that if I hadn't actually done this, this cap would have blown up. Thinking a graphing library is going to be a lot more work in the sounds. No, just replace it with whatever one it was I used for my internet ping nonsense. Because this one sucks and the other one sucks, but they suck in different ways. So, like, you can see kind of here that there's a crosshair that shows up. I'm supposed to be able to hover over this and then read the numbers that are down here, but it doesn't work. It's never worked. I'm sure it's a configuration error on my part, but pass. I don't need that, actually, at all. All I need is the graph. We're actually starting to see some curves. So if I take a full wooden ruler here, we can see that that's actually a pretty significant curve. So it is actually doing more forming up here. That's what that curve means. It means that the slope is decreasing, and it's taking longer to get through these steps. So it is reforming. But we're at the pretty high end of the scale now. That's 12 right there. So it looks like I would say it started forming around 8 volts. It's fun going through this and understanding the chemical process and in trying to interpret these results into that. Slope equal differential capacitance. Slope equals charge rate. So the stair step is the target voltage. The blue is effectively the voltage that the capacitor actually is. It goes through a current limiting resistor. Unfortunately, I'm not measuring this. This is part of the reason why I want to rewrite this so that I can actually directly measure the capacitor now that I have multiple DMMs. Beep again. It's done. That looks fantastic. Like I said, I want to run it one more time at a lower current rate. So that took like 3 minutes to do. That's not too bad. I'm going to do this at half the current this time. So 1.5 amps to 3 amps, milliamps. Verify 2. So what I'm looking for here, I want to see if we get, and it looks like we might be, maybe that's okay. I want to make sure that the angle is correct, because here's what I was trying to say. So we can see a little bit of curve there. We are limiting the charge rate by limiting the amount of current that can be used to charge the capacitor up to this voltage. So the target voltage here gets set, and that's what the red line is. Every time the target voltage changes, that is reflected on the red line. The current is limited through the current limiting resistor, so we have the maximum current output that the power supply is set to. Actually, we may not be current limiting the power supply now that I think about it. That's dangerous. The current is limited via the resistor, though. So we use math to calculate the next target voltage for, Ohm's law, to calculate what voltage step for this would result in a 3 milliamp maximum current, and then we stay there until we hit a minimum threshold of current passing into the capacitor. Then we step up the voltage again. So the slope of this tells us how fast it is currently charging. So at a aggressive slope, it's charging really fast. The capacitor is very low impedance. It's a very healthy capacitor. The slower it is, the slower that the capacitor is charging, the higher internal impedance there is. Likely, the worse the capacitor is health-wise. Now, because I have heavily restricted the current here, we're going to see a more dramatic change in the curve. Actually, it's not bad at all, considering we're almost at full scale now. But you can definitely see up at the top end here, above 12 volts is right there. We can see the curve is starting to be more severe. 12 volts could be the rail that this was on, because it is a 15 volt capacitor, so that would make sense for it to be 12 volts, and that it was mostly held at 12 volts throughout its life. So below that, flat line, above that, curving, because this was not formed well over time. But yeah, we can see when it's reforming by how slow this is, because the capacitor is in worse shape there. It's taking longer, using more current to form with electrolysis the the dielectric barrier. So that's why I look at that stuff. More leakage current slows the curve. Yes. Well, you are correct. Leakage current would increase current consumption, which would actually drop the voltage. So yeah, you can get the real voltage out of the meter. So Paul Guy, no, because there is no voltmeter directly on the terminals of the capacitor currently. I would like to change that. That's why I bought the two 3478As, because I would like to have one of those on the terminals of the cap. 1.5 amp would be done in 3 milliseconds, yes. Just hold a ruler on the screen to make it slow or fast or flat. Oh my gosh, brain. D3. I don't know what you mean by D3. No. So this is taking a while because this is like the top end. This is to be expected. This is a pretty aggressively slow value here. We're at 1600 microamps, so 1.6 milliamps. Actually, we're starting to see the slope go down here. That's not good. So if I increase the small window to say 500 samples, maybe I want more. Let's try 1500 samples. I think I want less. Let's try 50 samples. It's really hard to see, but this line is going down. That means there is some leakage current at the top end. But the weird thing I found is if I leave it here, it will correct. So we're going down. That means there is leakage current that is overwhelming the reform current. We probably reformed, and now we're at leakage. But I found if I leave it sit here, it'll go back up. So let's see what happens. I do not fully understand this. This bothers me. This is making me think when I put voltage to this thing's going to blow up. Clients, oh, graph stuff. Okay. Yeah, I don't need fancy graphs. Again, I just need bare bones minimum graphs so I can look at this and go, yes, that's what the capacitor's doing. Right now it's doing bad things. Yeah, I don't like the graph going down. It would be cool if I could, do something where we could see the graph in more detail. That would be nice. But we don't need that. It's also nice to be able to do a pinch zoom on here, kind of, because if I change the window size at all, it just breaks everything because it's calculated from the initial window size. This is the monitor I read chat on normally, by the way, so that's why I keep having to walk over to go read chat. Where's the plexiglass shield? It's in a box off to the side. I'm not, like, if we were dyno testing this thing, I would be behind the bell housing. It's down here. It's not over there. It's still in the chassis down here. But again, though, it's only drawing 1.7 milliamps. It's not like it's going to blow up. Although it's at full charge, so it does actually have a lot of energy in it currently. Current, ba-doom. Might want a plate glass shield, yeah. But no, there's a giant metal box that it's inside of it. I'm not on the other side of it. Come on, flat line and go up. You know you want to. I think it's at the asymptote, so it should start to pick up from here. The current here should start to go down, and the line should start to go up. I think we've hit the bottom. So we're at 9.2, 9.3, 9.5, 9.2, 9.4, 9.3. Yeah, we're holding now. So I don't think it's going to drop. I'm going to let it have time. I'm going to let it dwell there. Actually, I'm really happy to have it dwell at such a high voltage. At such a low current. Little concerning it didn't do this on that first verify pass, though, isn't it? Also, look at the big swoops here. Yeah, it was definitely doing some reforming up there still. And again, this is 12 volt. Big difference above and below 12 volts. So I'm pretty sure that's a 12 volt rail that it's sitting on. It's 1/4 of a watt going in it. Cap should be getting lukewarm. Glad this isn't a heart monitor. Shelby asking. It's a flat line, yeah. 15 volt DC working voltage cap. Yes. 15. No, the capacitor is rated for 15 volts, so it's probably on a 12 volt rail. Yeah. What's the rated voltage? Again, it is a 15 volt rated cap, so I'm assuming it is on a 12 volt rail, which is why I keep pointing out that everything above 12 volts looks worse than everything below 12 volts. I think one of two things happened with this thing, all right? I think it was either used a lot and left on all the time and has depleted some of the electrolytic, or it was used very briefly early on and then never used again, and the electrolytic has just decayed a lot. I can't tell which it is. But this cap is in a sorry state. But it doesn't appear to have actually failed. So in the 95th percentile, you'll start seeing get cranky if the cap is getting dry. That makes sense, yeah. But, well, here's the thing. It's done this at like 5 volts, too. This exact same thing. I've seen this exact thing happen at different voltages. If you go earlier in the stream, you can see a log where it looked like that. And after this, I could actually replay that log, and then you can see it. It's going to behave poorly, though, and do the lines drawing back to 0, though, unfortunately. So we are flatlined, but we are reducing current. So I said we were at 9.5 before. We're at 8.1 now. So the current is reducing. It's going to start going back up now. So we have reduced current draw by 10 microamps. Guessing it's gotten dry. Yeah, probably left on all the time. That's my guess. I don't know. It's really hard to say one way or the other. Because the other thing is that it is in phenomenal cosmetic condition. And it doesn't seem that dirty inside. So I don't think the fan was running all the time or it was cleaned. I don't know. I don't see the usual signs of high usage. .74 microamps now. So it continues to drop. It's running at 12 volts, see what the leakage is once it gets warm. So, Philip, leakage test, just apply 12 volts to it and see how much current gets drawn, right? Just plug it to the wall and let it go. No, I don't think so. Electrolytics have a derating curve? Probably, but I mean, they're Sangama. I could probably find a data sheet or something if that's been preserved. Friends use unmoistened caps. If I could get a bottle of electrolytic and squirt it back in there, I totally would. I would 100% do that. Have it be like that fake canister of IBM smoke? Yeah. Is that a thing? I mean, I could squeeze some pickle juice in there. That's an electrolytic, kind of. Setting voltage should not hurt. If it has reached equilibrium room time, okay. Only heat and high ripple current, heat it up, the real killers. Well, leakage current would cause it to heat by acting as a resistor internally, but it would be limited by how much leakage current there is. Gatorade for capacitors, yeah. Surely the liquid being electrolyte with electrolytic being the principle of operation. Yes. Yeah. Just to be pedantic, you're correct. Pickle juice, like the brine, pickling brine, okay, is enough of an electrolyte that you can use it for electroplating. Ask me how I know. There. The line went up. Time to put all your money into 15-volt capacitor stocks. So we're at 35 microamps. It's 1,635 microamps. I'm just talking about the least significant values because it's changing very, very small amounts. Favorite type of pickle? Mrs. Klein's hot dill. Sure, all you need is some table salt dissolved in water? Yeah. Yeah, I electroplated a stainless steel screw with a sheet of aluminum in pickle juice before. Mostly to find out if I could. The answer was yes. Unfortunately, a video did not metastasize from that because the goal was actually to, and I still think I could. I just didn't get back to it, and the whole process is difficult and messy. The actual concept was to take a PCB that has capacitor damage on the traces and replate it using like a copper pipe from Home Depot and a bath of pickle juice. But it's not trivial to set it all up. 2% white vinegar for nickel plating? Interesting. Wouldn't that damage the rest of the board, though? No, because you only power that one trace. And that's the trace that has the solder mask scraped off so that you could clean the leakage damage. In theory, that should work once any corrosion is cleaned off. I know, right? Wouldn't that be cool to see in a video? Get a bucket of pickle juice, PSU in a pipe. What's the issue? You have very, very significantly contaminated the pickle juice after you are done. Very. And I did not want to figure out how to deal with that level of waste. But yeah, it wouldn't damage the rest of the board because you would have positive, if I remember correctly, on the pipe, the source material that donates, negative on the one single trace that is bad, that has the solder mask scraped off. The copper ions, I'm not exactly sure what they would be considered. The copper particles would flow from the pipe to that one trace because technically electricity flows backwards. If I'm remembering correctly, the polarity might be backwards. It's been a while since I did electroplating research. So it should only go to that one trace because that's the only thing that would have a charge differential. As long as the rest of the board was neutral, it wouldn't matter. You could do whatever you wanted. That's how you can plate vias after a board has been masked and then drilled. They would be ionized in that process. Okay. How'd you deliver power to just that one trace? It's a circuit board. There's all kinds of ways. It'd be really easy. Just make artisan pickles with leftover juice. Oh my gosh. If you reverse the polarity, you can get the corrosion off first. That's hilarious, but I would be nervous about damaging the board more. I'd rather abrasively and chemically clean it. Could you soak the electrolyte in like a cotton wand? It's not about... I mean, you're talking about just landfill disposal. I don't know. It's just one of those things where like that's definitely something where you're supposed to dispose of it properly. It is a hazardous chemical byproduct at that point. You wouldn't want it in your groundwater. So I don't know how it would be handled. Basically, look, all you need to know is Motorola already yeeted South Scottsdale. That's a little bit akin. Oh gosh, do they have some kind of industrial problem I'm not aware of? Your place not offer hazardous drop off, dude. I have to fight to be able to even use the dumpster here. I am not kidding. Okay, I have had trash buildup from the mail video. Okay, I've been waiting to try and use the dumpster. It gets filled by, I'm presuming, apartments somewhere. 2 days after it gets empty.
201. Welcome to the HEV.Markiv protective system. For use in hazardous environment conditions.
End of line.
Swarm, thank you for the 201 bits. Just imagine the conversation with hazardous waste drop off at the dump. This junk contains copper contaminated pickle juice. Yeah. Copper 2 pickle date. So yeah, I have a hard enough time just throwing away regular trash. It seems ridiculous to like package trash to take home and put in my can there. I might have to though. Do the project, make a video. You'll dispose of it? Okay. Digging a hole in your backyard and burying it there doesn't count. The other problem is, like, I don't know what kind of fumes it gives off. It's just, yeah. It is slowly creeping up. Yep. Don't ask questions. Yeah. Well, Artemis, that's just because they got to keep the pizza away from the rats. There are copper compounds that have agricultural uses, spray on the grapevine, so copper isn't the worst thing you can introduce to a wider ecosystem. Ah, yes, but every marine life animal would care to disagree. Dilution is a solution to pollution. Every time, like, that's enough water. Oh, gosh. I mean, there's already enough, you know, metal contamination in there after people throw away their handguns. It is definitely starting to creep up over there. Marine life in the desert, though, the water always goes somewhere. Technically, it shouldn't be transporting anything other than a Transport Canada approved canister, except that then I might have to give that to the fucking dump. Ooh, that sounds like it could be expensive. Yeah. Fumes are minimal. Hydrogen off gas, mostly skin contact with copper and nickel solutions. Okay. So yeah, it's one of those things where sure, I can do electroplating. It's not a complicated process. It's DC power, electrolyte, metals. It's all the other stuff around it. Also feels, excuse me, somewhat irresponsible to do a video about it flippantly, to make it seem like it's a safe, easy process, when it's very much not. Yeah, we can definitely see the multiple stair steps there. If I close the window down a little bit more here, we might see the slope a little more obviously. Yeah, it's really difficult. It's also right on the edge. Oh my gosh, it's going to trip any second now. We're 4 microamps away from the trip point where it ends. 2.9, 3.9. Boom. Okay. Yeah, isn't that weird, though? The dip down? I don't get that. So my best guess as to what is happening here is that there was a portion of the dielectric that was weak. And when I ramp up the voltage, it hits that, and then it failed at that point. And then it had to be very significantly rebuilt. That's my best guess. If there are any other interpretations of the dip and then the climb back, I would love to hear them. Because, yeah, as far as I can tell, it would only be a rebuilding of the electrolyte there. Or not the electrolyte, the dielectric. Lots of Bill Nye moments. White lab clip, rubber gauze, yeah. Cap sad, now Cap happy. I mean, maybe. That makes sense? That's my best guess. But then the weird thing, why didn't it fail at the higher current rating? It only seems to be exposed at lower current ratings like this. Does the higher current rating not dwell long enough? Because we could see it took it a little while. Does it not dwell long enough and then my software cuts power and drains it so it doesn't sit there for long enough for it to start to weaken? I don't know. Makes me, again, real nervous that something's going to happen when I put full-scale power to it. We have a spike. So the spike at the end is the target voltage being increased, but then the software detects that the target voltage is now beyond the actual end voltage, and then it stops it. Cap might be good enough. I think it might be good enough. I think you're right there. All right. Tomorrow on stream, we'll start the 60 volt. I don't know that it will finish this weekend. I'm not looking forward to it. We're going to start slow. We're going to start at 1.5 milliamps with it. We'll probably do that 1 to 30, and then I bet I'll probably change it to like 3 milliamps to 5 milliamps to go from 30 to 60, well, 50. Because, yeah, when you get into the higher up voltages, it takes a little more oomph to do the dielectric. Who knows when it goes to storage, maybe it gets used a few years later. Yeah. Just set it on a series of really aggressive charges. Yeah. What device are we reforming caps for? A Deck Rider 2. So Ruben Berry hazardous waste. Oh my gosh. You are... Grief. Let's do this. Should we... Here's what I want to do. Okay, so it's currently discharging still, so it's down to 3.2 volts. Before we wrap up today, what do you guys think about me? I can't pull the cap out, but I could bypass the current limiting resistor and then connect it to the power supply and multimeter, and we can see what the leakage current is by just directly sending it, say, a 2 milliamp power source at 15 volts. Maybe we drop it. Let's drop it down to 12 volts. So we set the power supply to 12 volts, 2 milliamp limit, and then see what it gets to current draw-wise. Do it? All right. So we're down to 2.6 volts. That's probably safe. Okay. I'm going to bypass... Here, I guess I can kind of, sort of show this slightly. By the way, this was going to be the video for this week, but as you can see, it's taken forever. So we're not gonna get it done. Okay, so these go to the cap. This is the current limiting resistor and some adapters to just have everything be connected. So pulling this off, that's the 220 ohm resistor. Okay, this is just a extension to go to the power source. This goes off to the positive input of the multimeter for reading current. So this just needs to be connected. Oh my gosh, I literally can't. It won't reach. I have it going through a thing on a C-clamp here, so it's really hard to knock it loose. Will this? Nope, you gotta stay clamped. Can I reach? Maybe if I pull it back a little more. There we go. Oh, it's gonna be tight. Wait a minute. I just let loose this. So I can plug this into here. Yeah, that'll work. Okay, now I have all the space I need. All right, okay. Push that back away a little bit. All right. Let's see. You figure it's likely where dielectric's been chemically at for a long time, so 12 forming new that explains the curve you noted above. Yes. That's it. That's exactly it. Yes. Okay. So I will have current rating here. Boom. Current is minus 1.1 milliamps. I'm gonna local mode this VSET. Let's iSet 0.2. That's 200 milliamps. Never mind. iSet 0.002. Okay. So we're currently discharging the capacitor. I'm going to VSET 3. OV, hold on, reset. iSet 0.002. VSET 3. Okay, there we go. So it just charged the cap. We're at 3 volts. Currently leaking. Well, it's filling in the corners of the capacitor. So at 3 volts, leakage is 0.5 milliamps and dropping. That seems pretty good, actually. I don't think that's a problem. Here, you just want to see, I'll just call out the voltages. So that's our leakage current. That is DC current. So no leakage current at 3 volts. So I'm going to set VSET 5, just so you can watch it jump. I guess the terminals are backwards, whatever. No, it didn't. Oh, it went into OV. Over voltage. OV set 55. Weird. I don't know why it tripped. I think we had this problem before and it was weird, and I don't know what it is. Out, off, on, reset, VSET, okay, enter, output on. Then it goes into OV. Dude, what's the matter with this thing? Again, I know we've experienced this weird problem before. No, I'm not familiar with any quick and dirty methods because I always do obsessive and over the top. Okay, 6633A here. All right. Reset. Okay. We're current limited iSet 0.002. So 2 milliamps. Oh, hold on. I don't think that took. 0.002. Enter. Okay. Output. We are at constant voltage. We're at 5 volts. Okay. I think we are. All right. So we can't really see a reading up there, but up here we can see 200 milliamps, or no, 200 microamps. Plays audio through them and listens to the effect on the signal. That is a way. All right, so at 5 volts, 70 microamps leakage and dropping. Okay, I think that's going to be good. VSET 8, enter. It went into OV again. Dude, this is so frustrating. Reset. VSET 8, go. iSet 0.002. Go. Okay. So it is limited. Why are we pulling 7 milliamps? Again, I do not like using the power supplies at extremely low currents. They are unreliable. All right, there we are. We're at 8 now. So we're getting close to the target voltage of 12 volts. So out of curiosity, because I actually don't know what value would be acceptable, what would be a good 12 volt leakage? I mean, ideally 0, but what do we think would mean like, it's good enough? 10 microamp? Okay. I think we should just bump this up to 12 then, because I think it's going to take a while for it to settle at that. Output off. All right. VSET 12. Output on. It overvolted. I set 0.000. No, hold on. Clear entry. I set 0.002. Go. Let's see if that actually. I set 0.002. Reset. Okay, are we actually going to go to 12 now? I think we might. Okay, I think we're going to actually go up to 12. I'm going to go grab my phone really quick. So yeah, this is a very high precision multimeter here. It's currently set to a not super high precision mode for speed for the cap reforming script, but it's good enough for right now. I could change the precision if we really cared, but it's going to be good enough. Okay, we are at 12 now, so it's dropping. And sub 1 milliamp. Datasheet correct. Old caps, which will never be great as long as they have any kind of thermal runaway. So they don't hit a thermal runaway, yeah. That's what I'm concerned about. So what happens is the higher the leakage current, the more internal heat the capacitor builds, the more it decomposes the dielectric, the more it has to rebuild the dielectric, which also gives off heat, and that's where you get the thermal runaway of internal resistance or leakage causing the capacitor to blow up. I mean, we could cheat this test by setting it to 13, still dropping pretty quickly for 12. Yeah, I was going to say we could set it to 13 and then drop it back down and see where it settles. That might actually be faster. I've never done this test, so I don't have any benchmark or frame of reference for how this is performing. It is still dropping. Yeah, I wanna cheat. VSET 13. It overvolted, reset. Okay, VSET 12. Go. It should discharge the cap to go down to 12 now. Okay. So it overshot and then it undershot. So let's see. Does it hold at 1/4 of a milliamp? Or does it continue to lower? Emulate a constant current after power on. I don't know. I was feeling lazy. And we're over time now by 6 minutes. I kind of want this to end. So it is still dropping. It's just very slow. I mean, that's a lot more than your 10 microamp, but I don't have a frame of reference for any other caps. So there are 2 other Sangamos in here. There are 40 volts each. So we could literally just move the clips over to those and try them. We're not doing that today. Yeah, it's still dropping. It might be fine. Let's leave it connected like this. And we see it at stream start tomorrow. You want me to leave a potentially bad capacitor connected to power overnight? Additionally, it will not be on tomorrow when we get here. Literally every day I've come into the office this week, I have set my clock to be back on, and when I come back tomorrow, the next day, it's off again. The power keeps going out here overnight. I don't know why. All right, well, it's still dropping. I think it's probably going to be fine. It's at least going in the right direction still. We do have to wrap it up here. I need to remember that this is not set up for reforming right now, that this is over here. So if I don't deliberately say the current limiting resistor is back in tomorrow, make sure you tell me. Good experiment with the DC. Yeah, so it's still dropping. It's down to 1.7 now, or 0.17 now. All right, yeah. Maybe it's fine. We'll find out when I eventually turn it directly on. So, all right. We're going to wrap it up here. I'm going to hit the outro button. Boom, there it is. Okay. Well, yeah. We did literally nothing with the PyDescript software today at all. We confirmed that it could do a ISO 9660 file system disk yellow book, but we didn't actually accomplish anything other than finding out that my USB hub was flaky for some reason. So we'll look at that more tomorrow. Hopefully not, since I plugged it back into the computer directly. We'll see. I don't know, man. Too much other stuff going on. So, all right. That's it for today. If you enjoyed this stream, you may want to follow to be notified when I go live again next. We will be doing more of this tomorrow, but it's not going to be the main focus because it's just going to take all day. You know what? I'm probably going to restart the forming before we actually go live, because I'm going to get here like at least an hour earlier than the stream start, maybe 2 hours earlier. And that's a lot more time that I can get on the reform, and it's probably going to need all of it. So I might start it before stream tomorrow. We'll just see what the results are mid-stream. So did more than I did. Great success. All right. Well, okay. Let's call it there. If you enjoyed the stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. But that's going to be it for now, and I will see you next time. Phone's trying to let me know that I need to wrap it up. So I'll see you later. 0.15 milliamps, by the way, or 150 microamps.